Hey Opties! Today we're on Khan Academy looking at multiply and divide rational expressions basic. Yes, I know we haven't talked about this in our notes, but if you know how to simplify rational expressions, then multiplying and dividing is really not much different. You just need to know how to multiply and divide regular old fractions. So let's look at this example here. Divide the following rational expressions and simplify the result. Okay, so if we think about regular fractions, let's say we have 1/2 divided by 3/2. This is the same thing as multiplying by the reciprocal, which is another way of just saying we're going to multiply by flipping our second fraction. That's what a reciprocal is. You're changing the position of numerator and denominator. So now that we have our multiplication set up, we just multiply our numerators and denominators. And we have 1 times 2, which is 2, divided by 2 times 3, which is 6. And of course, which we could have seen here, these 2's simplify to 1, and our final simplified version is 1/3. So that's the process we're going to use here with our rational expressions. So 5 divided by 8 to the 6th. I'm going to rewrite that. And if we're dividing, it's the same thing as multiplying by the reciprocal. So our new numerator is 6a to the 4th. And our new denominator is 5. Okay, right off the bat, we see that we have a 5 in the numerator and denominator. So those simplify to 1. And we also see that we have some variables in the numerator and denominator. So before we get too crazy, let me write it this way. Let's break down our 6. 6 has a common factor of 2 with our 8, so I'll rewrite that as 2 times 3. And then we have a to the 4th, which is 4 a's. Our denominator is 8a to the 6th, which is 2 times 4. And then we have 6 a's, 1, 2, 3, 4, 5, 6. Okay, we're going to simplify all of our monomial common factors like we did in our other Khan Academy assignment. So the 2's will simplify to 1 just like our 5's did. Our 3 and 4 stay, but then we have 1, 2, 3, 4 a's that simplify. And we have 2 left in the bottom. So now our final answer is 3 divided by 4a. So let's write that in here. 3 divided by 4a. And we have to decide is, for our second portion, for the result to be equivalent to the original expression, can it be defined at a equals 0? In other words, is it okay if a equals 0 here? The answer is no, because if it does equal 0, 4 times 0 equals 0, and our denominator cannot be equal 0, so that's a big issue. So no, it cannot be defined at a equals 0. So let's check. Okay, so I did get this wrong. I realized that I forgot these 2 a's, so that should be a squared. So let's fix that in our denominator, and then we should be good. Okay, so now let's check, and we're good. See, don't forget that, and make sure you write down all your steps, so if you do mess up something, you can go back and check to see what you did mess up. Here we have a multiplication one. Multiply the following rational expressions and simplify the result. Okay, so we just multiply our numerators and multiply our denominators. We get 4 times 1 divided by 5y cubed times 12y to the 6th. Okay, so our numerator is 4. Our denominator, really before we combine our 5 times 12, we could go ahead and see if there's anything we can simplify with our 4. And there is, because there's a 4 in our 12. So instead of writing our 4 here, we know that's going to simplify to 1. And 12 divided by 4 is a 3. So really all we have is a 5 times 3, which is our 15. And now we have to figure out how many y's do we have. Remember when we multiply like a variable to an exponent, we're going to add those exponents because we're just counting up how many exponents we have, or how many variables. So 3 plus 6, 6, 7, 8, 9, that's y to the 9th power. So here's our simplified form. 1 divided by 15 to y to the 9th power. So we'll do a to the b, put our 9 there. Okay, so for the result to be equivalent to the original expression, can it be defined at y equals 0? Well, y is in our denominator, and it's multiplied by just a number. It's just a monomial. It's not plus or minus anything. So if we set our denominator equal to 0, then we get y equals 0, which is our restriction. Y cannot equal 0 because we can't divide by 0. Even if we looked in our original without any of our 4 being simplified, that's still true. So can it be defined at y equals 0? The answer is no. Let's check, and we're good. All right, Opties, that's it for multiply and divide rational expressions basic. See you next time.